This is a special board meeting of the Waterville Valley Select Board for Wednesday, 30 October 2024. I am Rich Reeder, the chair, and here almost always is Bob Freeze, the vice chair, and Wendy Rathgeber, the other select board member. So the purpose of this special board meeting is to listen to the presentation, the wastewater treatment facility project presentation by the town engineers, Black and Veatch. So Mark, why don't I turn it off to you to give an intro and
Sure.
Let's move on.
Great. So everyone has handouts and we'll have copies of those handouts available over at the post office up in town hall if people want to get them as they watch this online. I'd like to begin by stressing that the information we're going to discuss today comes from a careful analysis of information regarding the different available wastewater treatment processes as we look to replace our current treatment plant. This isn't a final step in the overall project. In fact, we're at approximately the midpoint of the project right now. Our goal today is to update the board and the town on the different treatment methods we have looked at and provide you with a summary of the analysis of those treatment methods. Please keep in mind that the site plans that we look at are conceptual only at this point, and the cost estimates that we're going to talk about are only for the treatment processes, not the entire project. This is not a complete plan at this point. Mario is going to take us step by step through the information slides and address any questions that the board has in just a second. I would like to say we're going to try to minimize the questions. There's a lot of material that we want to get through, but if you have a question, please interrupt us and we'll address it. Okay. At the end of the presentation, if the board agrees with the recommended treatment process option that's being recommended by the engineers and town staff, then we will continue and begin more detailed design work and planning of that preferred option all the way through a 30% final design level. And that will give us more detailed site plans and cost estimates for the project. We're also going to provide today an updated project timeline. But when we complete the 30% final
DOT.
design point, then we will really have an updated timeline. So what we show today is just going to be in general terms for right now. On behalf of the town staff, I want to thank Black and Veatch for their thorough review of our current facilities, our permit requirements, and the wastewater treatment needs of our community to date. They've been very responsive to questions and concerns that Dylan and Rich have raised during the past 8 months, and they've provided additional analysis as we've asked for. And we're very confident that the information we're looking at today is well-founded and has been already vetted by the town staff. And we're very satisfied with the total commitment that Mario, you and your team have displayed to the town and our needs to date. So thank you. So let's get down to the presentation.
So my name is Mario Francucci, has already been stated by Mark. My associate and project manager, Will Walkup, is also here. We have Patrick Dunlap, who some of you have also met before online. So we're going to get right into it right now. And thank you very much, ladies and gentlemen, for listening here. So we'll put the presentation up and we'll go right to it.
I think you're going to have to plug in. I thought we did.
You want to see if it'll come up on this?
Yeah, what's going on for that one right now?
So it looks like this is a different file.
But it's not PowerPoint, Will. That's why you're gonna have to, you're gonna
Yeah,
have
this
to,
one has a
plug
PowerPoint on it.
no, that computer may not have
Oh, I
PowerPoint.
see.
That's what
To
the
be-
problem
okay,
is.
Okay.
So we'll plug in directly.
With this.
So you're still running the meeting on that computer.
That's fine.
Yeah. Sure. Eliminate that screen.
Yes,
Yeah.
they're just gonna lose the slides. Yep.
Sit next to you. I was gonna sit next to you today. Yes.
And source.
Like this, so we can.
Yep, that way the folks in. Good.
Yes. Yeah, okay.
Okay, I think we're ready to go. So again, I also want to thank staff, before I start. They have been completely responsive. We don't believe in operating in a vacuum. We need to do our homework, but, we vetted, literally every major action with Dylan, Rich and Mark and others along the way. So we feel like at this juncture of the project, we have not only, done what we needed to do, but really collaborated with staff as is to provide a well-founded project. So again, today's project, as Mark said, we're looking at the liquid stream treatment process. There's other parts of the plant that we have not yet looked at, like residuals management or what's called sludge management. We haven't looked at operations and administrative facilities. We have not yet begun work on the subsurface for foundation pipelines and all the conduits and electrics that's needed to really make this plant alive. So those aspects have not been done, but we have a foundation here for the plant, which is really the heart of the plant in terms of treatment is concerned. The liquid stream treatment drives the rest of the process. And what we've tried to do, very simply, what we've tried to do is what treatment technology should we be identifying and recommending for this new treatment plant? There are many types of treatment facilities and processes that are available, but which one is the one that best suits Waterville Valley's condition in terms of its permit, in terms of the climate, in terms of the cost, and in terms of the footprint. And we've endeavored to narrow it down to that, to answer all those questions, and that's what we've tried to do here. We've produced three major, what we call technical memoranda. That's what we're gonna do a quick review on. by the way, we've prepared hundreds of pages of material and maybe even more hundreds and thousands of backup. So I'm gonna be trying to go through this quickly, but at the same time, the worst thing I can do is to lose you completely. So I'm gonna try my best not to do that. So we've developed flows and loads. Then that's a Tech Memo 1. Our Tech Memo 2, we've started with this universe, or kind of a controlled universe of technologies, and we've tried to narrow that down to 2 treatment technologies that we could really dig into more, develop further, and evaluate further. We call those the finalist alternatives. And then Tech Memo 3 shakes those 2 final alternatives out and comes up with the recommended alternative. That's the process. It's a pretty a standard process, universally recognized process in engineering. We apply it to different type of facilities as well, different type of public works infrastructure facilities that we do and other engineers do. So we start off with Tech Memo 1, the flows and loads. Basically, we needed to understand what the plant's current flows and loads were. We needed to understand future development, and then we needed to come up with what is the basis for the plant as we see those things. So we met with the folks from Terrell, who are going to be developing the core area of town. And we've identified on this slide, just not for your consumption here right now, but we've identified all of the different type of facilities, rooms, restaurants, and we've quantified those in terms of what are the corresponding wastewater flows that are going to come out of that. And we came back with what we're calling our loads and flows and loads basis of design. And we've grouped that into 2 areas. We've grouped that under the current condition and the build out condition. So the current condition is what you have right now, what's going on right now in town. The treatment plant must be able to accommodate that. And the treatment plant will be able to accommodate that. But then it also needs to accommodate, when that build out occurs, it also needs to accommodate that future build out for the entire facility. So we're comfortable that what we're laying out is going to be able to address both the existing condition and the larger condition in the future. So then, and that's what I wanted to say about TM1. TM2, let's take a look at the technologies. I don't want you to read these, but we're going to start off with a little bit of effluent requirements. What is required in this permit? We took a look at secondary treatment technologies. There's a whole list of them: lagoons with tertiary treatment, conventional activated sludge, sequencing batch reactors. We got acronyms to spare here. We got tertiary treatment technologies, and then we've got NBR, which actually is able to do both secondary treatment and tertiary treatment together. So the NIPD's permit that the town has and is required to meet has a lot of different parameters, but a couple of them, 2 or 3 of them, are very strict. As a matter of fact, in all the work that we've done, we've only found 1 other treatment plant. That doesn't mean that we've scoured the earth, but we have scoured a lot. And there's only 1 other treatment facility that we've been able to observe that has limits as strict as yours in terms of TSS. So we're in an unusual place here.
No, Mario, NIPD's is our permit from the EPA.
Correct.
Our
Yes.
federal permit.
National Permit Discharge Elimination
Yeah.
System,
Okay.
but EPA, correct. So the TSS is very strict. The ammonia is also very strict at 1 milligram per liter. And then you have an aluminum limit that's very strict as well at 87 micrograms per liter. Phosphorus is a little bit more typical. And then we have to monitor in this permit cycle for PFAS compounds.
You want to say what TSS is?
Total suspended solids.
Okay, I'm just. Thank you.
Okay. So basically, what we started off with this universe that I've kind of just briefly stepped through. But what we did was we started necking down, looking at this in two steps. So the first step that we did was kind of qualitative, and we said we wanted to check what is the ability of these treatment processes to really meet the permit without doing piloting. Piloting is a multi-month, 6-month, 12-month process. Could we avoid doing piloting? The DES, New Hampshire DES is going to want you to pilot new processes. So if we're going to recommend to the town to pilot, we better be sure that it's something worth doing. So that was very important to us. And because it also impacts the schedule, we also took a look at the practicality of that treatment alternative to fit within the whole. And so we were able to screen down a little bit just by doing step one. And then step two, we started comparing these alternatives using more quantifiable methods, like what's the footprint? What's the relative operational cost? What are the operational complexities? What's involved maintenance wise? So step one, we'll go through that. We looked at granular activated carbon. That's at the very tail end of the treatment process. You've got granular activated carbon. And so this graph, take a look at it just really briefly on the left. We took a look at the data, the plant data quite carefully. That 1 milligram per liter number is what the permit says, as I just said, for TSS. And you can see those blue circles up above the 1 shows that, as well as Dylan and the plant staff is running this facility, there have been a few excursions above that 1 milligram per liter. And that's without that's coming out of filtration, but not GAC. So GAC is able to take out those additional compounds that filtration does not take out. And so we found a benefit to retaining a GAC for that reason. We also took a look at aluminum, at ethyl aluminum. I said that was pretty strict too. And you can see, while the red line is the limit, you can see that there's a couple of spots where we're bumping up against that red line. And so GAC is also helping, in our view, also help remove and control the discharge of aluminum to the Mad River. So we basically said at the end of all that, we said, on the end of step one, we said, we want to retain GAC. GAC also provides flexibility for PFAS requirements in the future. Taking a look at tertiary treatment, we have two type of filtration systems that we looked at. One type is what the plant has right now, which is what we call conventional dual media filtration. The other is called a cloth media filter. Cloth media filters is new to New Hampshire. We've seen it. We have experience with it. It works well. But what this graph kind of indicates is that, as good as it is, we looked at a number of different plants, and not all plants with cloth media filters are able to get down to the low levels that you have here. So that allowed us to essentially put cloth media filters aside. Why would we want to recommend something that's not even as good as what you have right now, and you have to pilot it? It was easy for us to put that one aside. Taking a look at the secondary treatment systems. Okay, so I promise I will not go through all of these different systems, but we looked at conventional activated sludge, which is a very common secondary treatment process, very well understood, comes out with a lot of different configurations. That was our base. We wanted to study that. We have experience with all of these, with all these technologies. We have IFAS, which is a combination of suspended growth and fixed film process using high density polyethylene floating media to essentially create an attached growth environment. We looked at MBBR, which is similar, mostly also similar in many respects to IFAS, because it also uses an attached growth system, but it does not require a clarifier. Both of those two options also are smaller, typically smaller footprint options, so we kind of liked to see those. We looked at SBR as well, which is kind of a sequencing operation. You're basically using the same tank to do multiple things. You fill with the tank, once it's filled, you use it as a reactor, then you settle it and you withdraw it. So you usually have two treatment trains, and while one is filling, one is reacting, and then when that one is fully reacted, it overflows and it switches around like that. It's a nice process because typically you can use a smaller number of tanks to do a smaller number of footprints, a smaller footprint to do the same work. Then we even looked at a version of SBR that uses a granular sludge, which gets the footprint even smaller. Finally, we took a look at, hey, why don't we just keep our existing lagoons? And what we would do is we would put MBBR on the back end to try to use the lagoons to do conventional activated sludge, use MBBR to maybe remove that ammonia, and then to the filtration system. We looked at all those, and we also looked at membrane bioreactor, and by itself, that was the one I said that kind of does both. It does secondary treatment and tertiary treatment in one package. The advantages are it's definitely got the highest quality effluent of them all, smallest footprint, process capacity isn't limited by sludge settling characteristics. It does have higher operating costs, and you need to have a higher level of screening, pre-treatment before it as well. So we need to acknowledge that as well. So what we did was at the end of looking at all that, we decided to eliminate MBBR because of those ammonia limits that you have cannot be removed to the levels that your permit requires with MBBR. And so we also eliminated, and that not only allowed us to eliminate MBBR, but we also eliminated the process to retain your existing lagoons because it relied on MBBR on the back end of the lagoon. So we eliminated two alternatives, MBBR and the lagoon plus MBBR, and we would carry forward the conventional activated sludge, SBR, sequencing batch reactor, IFAS, integrated fixed film activated sludge, and MBR, which is the membrane bioreactors. So, that took us through step one, gauntlet, if you will, and all these steps took, a lot more time than I'd say, a lot of analysis, a lot of modeling to get down to that step. So when we started, now step two, I said before that we're looking at quantitative criteria, a little bit quantitative criteria. So we also used a number scoring system at this time. You'll see 1, 2, and 3. 2 is sort of neutral. 2 is kind of in the middle. The higher number is favorable. The lower number is less favorable. So 2 is the seesaw at fulcrum, and 1 is low and 3 is high. 3 is good. 3 is real good in this case. So the higher the number, the better. We also took a look at, the color scheme here shows green for secondary treatment and blue for tertiary treatment. And so you can see that the conventional activated sludge, the one that I've said is the baseline, has a higher overall footprint for secondary treatment And then IFAS and SBR as could be expected are a little bit less. And NBR, as you can see, is real small compared to those. And we also took a look at the relative operational cost. We still haven't really drilled down into operational cost here, but we noticed that IFAS is a higher annual O&M cost alternative because it requires greater energy. It requires greater energy. It has a less efficient aeration system, just the way it works. There's obviously other benefits to it, but it requires greater amount of energy. So we used it as the base, and then we kind of took percentages on the others. On the MBR, the reason it's higher also is because of energy requirements to scour the material off the membrane. It's a more higher energy intensive alternative. SBR and CAS were roughly the same.
How does manpower fit into there?
All the same.
They're all the same.
They're all the same. We're at this time, we don't expect that no matter what type of plant you would have, I think we can handle it with the same manpower. Different skill sets, probably a slightly different skill sets, and we'll talk about that, especially with MBR. But yeah, it's not impacted by staffing.
Okay.
So operational complexity, we sort of like grouped. There's a series of processes on the left, and we got this process MBR on the right. So let's talk about MBR for a bit. When we took a look at operational complexity, we started looking at how many different processes are involved here. Because the more processes you have, the more operational and maintenance activity you would expect. So with MBR, we have 6 major processes. So we gave it a 3. Remember, three is higher favorability. And we only have 1 sludge stream with MBR. So we thought that was an attractive. Some of these alternatives have 2 sludge streams. That's a favor to the point of MBR. And also it provides a very stable nitrification and solid separation process. So we gave that one overall a 3. The others were good too, but just not as good. Because remember, when we opened up, when we started identifying technologies, we didn't just start picking ones. We already knew we knew that the outliers, we made it hard on ourselves because why make it? We made it hard on ourselves to begin with. We came up with alternatives right from the get-go that we thought had a chance here, had a real solid chance here. So even though those ones on the left don't look as good as MBR, we didn't know that at the beginning. We knew it by the time we got to this point. So conventional activated sludge, SBR, IFAS has more unit processes. They also have 2 residual streams, and settleability and operability is a little bit more complex with some of these processes. SBR has more automation and instrumentation requirements associated with it. Conventional activated sludge and IFAS are a little bit more complex to operate from a process perspective. What we're trying to demonstrate in this slide is that we actually took a look at every major piece of equipment that these processes have with them. And you can see we got 13 major pieces of equipment. There's also sub pieces of equipment, which we didn't list here, but the major treatment piece of equipment we got with CAS, we've got 13, with IFAS, we've got 14, SBR, we got 14, and MBR, we got 12. You might say, so what? The real reason is that next slide is we said, look, we can't really distinguish whether between a third. We were looking to grade them. That's what we were looking. We were looking to grade them we said overall, they have similar number of pieces of equipment. MBR, yeah, we have fewer pieces of equipment, but we also recognize that membrane is a little bit more unique. Membrane technology is a little more unique. And we also said, but it doesn't have tertiary treatment. So we basically said, we're gonna score the same for all of these processes. Even though we're trying to distinguish, we thought membrane had a little bit more favorability, but it wasn't enough, at least to us, to give it a higher point score on maintenance. So the scoring comes out like this. After looking at the entire process, we said conventional activated sludge and SBR, they're tied with 8. Membrane is the best at 10, the higher the number, the better. And IFAS is at 7. So at the end of the day, what we ended up doing here is we still ended up removing SBR, and we removed IFAS from further consideration only because of the operational complexity. We had those were graded at 1, while conventional activated sludge and MBR were rated higher. So our 2 finalist treatment alternatives at the end of Tech Memo 2 is the MBR alternative and the conventional activated sludge plus filters alternative. So I know I went through that quickly. It took us months to get to this point, but we can talk about any questions that you have later. But that's where we ended up with that tech memo. We discussed all this with great length with staff here. So let's get to Tech Memo 3, because now we're only dealing with 2 treatment alternatives. You would think that it's easier. So what we did was we basically said, okay, so we're gonna, what are we gonna look at? We're gonna look at what is the real ability to meet permits. We started really looking hard at these, real hard. Are they better at one versus the other on its ability to meet permit? If it doesn't meet permit, why are we even looking at it? So it better be, we're looking at this plant as a very strict permit. I said that, I can't overemphasize that. We looked at operational considerations, we looked at maintenance, we looked at footprint, and we looked at life cycle cost. We looked at all these parameters. By the way, DES wants us to look at these things as well. And we've reviewed this with DES, we reviewed this work with DES as well. We met with them to review what we've done. So this is what these 2 processes look like. I won't bring you through every step of the process, but basically we have on the left side, what we have is we have preliminary treatment. And then that's where you've got the screens and the grit removal. And then the central part basically is biological treatment, which is the part that has AE, aerobic zone, anoxic zone, and the clarifier that's up at the top. And then we have filtration, and then we have activated granular activated carbon and effluent. Remember I said that this is a liquid stream treatment analysis that we did. Down below with membrane, we also have screens and we also have grit removal, but we have an extra step of screens. We have 2 steps of screens with MBR because the membranes, we don't want to foul the membranes. And so the membranes require, we need to take out even more material ahead of the MBR. And we were able to do that with a second set of screens. But then the reactor volume in the middle, the aeration zone and the anoxic zone and the membranes, they fit into one vessel. So in a way, MBR is kind of this hybrid process that does both biological treatment and also then does away with the clarifier because of the membrane separation ability. Membranes basically separate the liquid from the solids. And it does it with an extraordinarily level of removal, solids removal. Then we also put in the activated carbon, and then the effluent disinfection. So those are the two processes. And so I know I've said this a couple of times already, but that permit was real critical. Both of these two alternatives that are the finalist alternatives will meet the permit. MBR can meet a little bit better than the filters, than the conventional activated carbon by filters alternative. Dylan is doing that right now at the treatment plant. But MBR was not around then when this plant was built, and it can do it even better. So we with that, we base it, and it also provides kind of this double barrier approach.
Mario, just a quick question. Does either alternative distinguish itself for a more strict permit that could come, say, downstream, pardon the pun?
I don't think you'll get a more strict permit total solids wise, but I will say at the end, we've thought about what will EPA throw at the town in the future.
Right.
So
And the future isn't that far off.
yeah, the future isn't that far off.
26, I think, is that when our permit,
Permit cycles
first
are every
draft.
5 years.
every 5 years,
Yeah.
our first draft. is-
The
So
draft would be
So
26.
we've set these two configurations to provide a level of nitrogen removal.
Mhm.
Okay, so because that would likely be a place where EPA would want you to go to remove nitrogen. So we've set these two configurations to enable nitrogen removal. And also the GAC on the back end will allow us to have a chance at removing a certain number of PFAS compounds. And since you're already monitoring, that's what the regulatory agencies like to do. First, they let you monitor and they say, oh, great, let's remove, in the next permit cycle, they'll let you remove. So I'm not saying that that's what they're gonna do, but that GAC not only does it help remove those very low solids with the CAS plus filter alternative. The membrane can do it on its own, but it really sets you up nicely for that step to where PFAS is likely to occur. For removal. That answer the question there?
Yeah, I was thinking of PFAS in particular. Seems to be a hot issue.
It is, yeah. And so we took a look at the number of, remember, I'm stepping through that criteria, operations, maintenance, we're looking at that pretty carefully. So again, we took a look at all the major processes and we said, okay, CAS has 8 and MBR has 7. I don't want to downgrade one, but it's pretty similar. But so we even looked at all the equipment again. We looked at it again because we're drilling down further. You know, when we have 8 alternatives to look at, we're looking at them to a level, but once we get to this level where we're looking at 2, we're really putting a higher strength microscope of observation and review on these alternatives.
But just, I mean, you have the number, but surely fine screening versus tertiary filtration, those aren't necessarily equal, like. in
Right, did
terms
you
of-
weight them?
yeah,
Yeah, and that's also in the eye of the beholder.
okay,
You know, sometimes I can probably meet 2 operators and then say, which would you rather that filter system at the end is a process, but does it really compare? But surely screening ahead isn't so difficult. I mean, but it can't very well, sometimes this is the tail that ends up wagging this dog. We have seen this so many times over.
okay,
We talk about a number of examples. I mean, what's coming down the pipe we are going to, if you agree with what we say, we're gonna pay a lot of attention to that pre-screening step. A lot of these membrane systems, if they do fail, it's because it doesn't have,
Right.
that doesn't set you up for success later. But we're gonna be paying a lot of attention to that screening.
Hmm.
So while it's less complex than the filters at the back end, the filters at the back end receive a pretty clean liquid.
Sure.
The filters up, the screens at the beginning is gonna be seeing some nasty material that it needs to remove. And remove consistently and remove all the time,
Okay.
okay?
Does DES or EPA have a preference on these two systems? That are they neutral on looking at both of them?
Well, I'll tell you what DES said about this. They actually they agreed with us with our recommendation. But it's about site specific, it's about, at the end of the day, Bob, it's about what is the best for you. I mean, that's why these studies need to be conducted and under every condition about site, about cost, about permit, about maintenance. I mean, it becomes a little bit subjective, but we really try our best to quantify it.
Mm.
And so both of them, there's no question that both of these alternatives would be something that Black and Beach would be proud to put our names on behalf of the town. We needed to choose one though.
Mhm.
So you got two options, you got two alternatives that are very, very good here.
Are either one more expandable than another? I mean, are we gonna build for the 22nd century? Or is it an expandable program?
Yep.
With one or the other?
I think they're both expandable, but can you, if you don't mind holding that,
Okay.
but we're gonna go right back at that question here in a little bit.
Okay.
Okay, so we've said pretty much from an operations and maintenance perspective, as hard as we tried to find a winner in that horse race of two horses, at the end of the day, we said, guess what? We're gonna call it even. We're gonna call them both even. The CAS and the filters is more challenging operations, maybe to more unit processes. But MBR, we just need to recognize that it's newer, it's a newer process in New Hampshire. Other parts of the country have it much more, have many more of them. And some more unique training requirements. We talked to Dylan about that. We said, we're gonna grade it, we're gonna grade them the same. We're not gonna be so right-brained about this. We needed to listen and get brought back into the middle as well as we know that they can operate well. They will. So we'll start getting to some of your question there, Bob. So we started laying these facilities out on the site. As Mark said, we're nowhere near being done. I'm gonna predict, like Mark said, we're about halfway done with this process. By the time we come back here a number of months from now, I'm positive that this site layout is gonna be a lot different. But this is a good starting point at this time. We applied the same level of precision to both layouts. And the CAS plus filter system, what we tried to do is we tried to fit it nicely into the space that you have right now. And you can see that it fits, but it's pretty tight.
Hmm.
It's a pretty tight layout. We've got the headworks just north of the existing garage. We've got the conventional activated sludge and filtrate and clarifiers. And then that newer parcel, and then we got the filter plant up at the top, heading towards the river. So I think it's doable, but it's gonna be tight. It's gonna be tight. It's gonna be some construction issues. And we haven't even done any geotechnical borings yet. And the existing plant, by the way, we've never forgotten that it needs to continue operating while the contractor is all over this site. We're probably gonna fly Dylan in, because I don't know how.
Yeah, it's helicopter every day.
Building a special road. So MBR, we got a little bit more notch on my belt here. There's a little bit more breathing room here. It's a more forgiving layout, this, with the space that we have. So Bob, now we'll answer your question. How are we set up to expand? We think we can expand with both alternatives. While we're not done, there's no question that MBR allows us a little bit more room to expand than the conventional activated sludge plus filter alternative. But I think we can set them. I think what we would do, Bob, right at the beginning, I showed you what those flows and loads are. And we're designing around that, but we never forget, as much as we know that that sort of represents the build out condition. As soon as I say that, somebody else is gonna figure out a way to bring more flow into this community. And that means more flow to come to the plant. So we'll be looking at ways to allow you to expand all the way through. I think we can do it on both. I think the answer to the definitive answer, the best answer I can give you, I think we can expand both facilities, but there's no question that MBR, at least on the area of white space that you see here, provides more than the other one.
Because presumably the existing building at some point will go away, which will
Yes,
provide some space.
yeah, we would probably put an operations center at that location, or fit it into one of the other facilities already. We haven't decided that. But yeah, that building would go away, would have no further use in the future.
So were we to mitigate the wetland area, that could be a usable area as well.
Yes, we've got some ideas there too.
Because that's a lot of area.
Yes. Yeah, there's a lot of work to be done in the next 9
Right.
months for sure, and we want to do it. Okay, so, but it gave us a real eye opener because it was the first time that we went from essentially from book to site, if I can use those words. It really started, even though we've always been aware of that site and everything we've been doing, but it's the first time, okay, start laying out on sites. It's amazing how the team just reacted and got into it. So all this slide tries to do is it tries to quantify all of the various areas from the headworks, the secondary treatment, odor control, residuals. You know, we try to quantify even those areas that we didn't study. We try to approximate what areas it needs they would have. And you can see that MBR has, you know, on the order of 16%, closing in on 20% less area needs than the conventional activated sludge plus filters alternative. And what that means at the end of the day is, so you might answer, so what? Even though it's, so basically with the footprint that you have, the site area that you have, that larger area will end up being an impact to construction and your long-term use. However, with MBR, it's the opposite. It provides a benefit. Less area with MBR provides you the ability to have more options in the future, and it allows constructability to be not as complex. Usually, if constructability is less complex, it means that a contractor can facilitate and do things in a more orderly manner. Usually that results in a more attractive cost.
So given the flows that we have in the resort right now, compared with the build out as you're proposing here, with the data from Terrell, whatever, what capacity we'd be operating at? 30% of total build out, 40%, 50% of total build out?
Yeah, so you're I bet anybody I'm sure knows these numbers better than I do. I've tried to do a pretty good job of it too, but right now you're on an average basis, the plant sees about 126,000 gallons per day. It could be off by 1,000, but that's it. by the time your full build out occurs, that's gonna go like, I think upwards of about 240. I could be off by a little bit, but about 240,000 gallons per day on on a day in and day out basis. Okay, so this plant that we're going to design and eventually construct to support you is gonna have to do all of that. Right from the get-go, it needs to be able to handle that 125 gallons per day, as if this never occurred, as if the build-out never occurred.
Right.
There might have to be a tank that's gonna be maybe sitting there or not doing as much.
So it sounds like 50%.
Yeah, a little bit less than 50%, I'd say initially.
And what about we haven't talked about the ski area yet, but how would that? If we don't have a septic system up at the mountain,
Yep.
how would that impact these numbers?
Right now, the ski area flows come to the plant already.
Mhm.
And so
So
those
it's part
are
of the
already,
125.
that already is taken into account in the plant that
Okay.
we've, in that base plant.
Okay.
Okay. Yep. And so then what we did was we took a look at budget level process costs for construction. And so we did the best we could. We did some quantification, but we don't have plans yet. What contracted personnel, and quite honestly, our own cost personnel do, they like quantities. They take quantities. How much concrete, how much steel, how deep, how much of it is below grade, what's the soil conditions, what's the groundwater conditions? We had none of that. What's the pipe work on the ground? The pipe work underground is gonna be pretty significant too. We didn't have any of that, so what we did was, we took a look at that headworks and preliminary treatment facility that we kind of schemed out. Said, what's the cost of that? You can see for CAS, it's gonna be a little less than for MBR, because I noted that on the MBR, we're gonna have 2 steps of screening. Coarse and fine, both of them are fine, by the way. 6 millimeters is what we're gonna be having for both. That's fine, but we're gonna have fine with following fine with MBR. So it costs a little bit more because it's a little bit bigger. On the biological side, again, because CAS is bigger, it's gonna cost more. On tertiary, you can see a big advantage to MBR because we don't have all that filter system. So, Wendy, to your point, surely these can't be equal. Well, they may not be equal on a maintenance basis, but on a cost basis, they are.
Hmm.
Okay? So total budget cost advantage to MBR by about $7 million, just total initial cost. Then what we did is, what we do at this point, and DES requires it, and we do it on all of our projects where we're comparing alternatives. What we're doing is we're comparing not just what the initial cost is, but what is the total equivalent cost. So what you've got is, you've got 2 treatment plants that have annual O&M assigned to them. O&M tied to electricity, O&M tied to chemicals, O&M tied to equipment replacement. And so what we did was, and O&M tied with staffing. So what we did here is we looked at relative. We did not, like, if you have your auditor come in here and tell us, oh, did you account for this? We probably didn't, because those costs are even out. They're about the same for either alternative. So we looked at the ones that really differentiate one to the other. So these are the ones we looked at here. So we looked at O&M, and we know this capital cost at the beginning. And so we need to compare these alternatives. Net present value or present worth allows us to do that comparison. It allows us to bring O&M cost back it allows us to essentially compare, unify capital cost and O&M cost to provide an equivalent cost to compare alternatives. The lower the net present value cost, the better. So we took a look at a 20-year planning period. Up here it's written 20 years of operation. We know that initially the plant is going to be running as it is right now with no expansion. So we said, okay, for the first 5 years, we'll assume we're at startup. When our terminology startup means current conditions. And then 15 years is going to be at that design full build out condition. So 20-year planning period is typically understood and accepted in this type of analysis. We looked at a higher, and what this shows is that top set of graphs shows that for operations, from an operation and maintenance perspective, MBR is higher compared to conventional activated sludge and filters alternative. But by the time you combine that capital cost that I showed you a little bit ago, by the time you combine that with the net present value of the O&M, you can see that MBR is still highly favorable from a net present value basis compared to the conventional activated sludge and filter system. And that's on the order of roughly about 25 to 30%, depending on which you use on your denominator. So that's a pretty significant.
That 600,000 is the whole 20 years, or
Yes.
that's not per year?
No.
That's
That's
the whole
over
20 years.
Yes, yeah. Yeah. And so what we did here was we basically said the CAS and filters, we're gonna give it a 1 on that scoring sheet. And the MBR, we're gonna give it a 2. I never want to, anytime I deal with costs, I never want to give anything a 3. So we said the best you're gonna get is a 2. So that's how we graded MBR. Okay. So at the end of the day, when we took permit compliance into account, when we took operational and maintenance into account, when we took site and footprint into account, and when we took economics into account, and this, MBR scores higher. The higher the number, the better, over conventional activated sludge and filters. And so that's the process that we've recommended to staff and to the town and to you.
Into DEW, I mean.
And to DES.
DES.
And DES has agreed with that. We went through a presentation, actually even longer than this with them, and we brought them through all of this. And so obviously, we recognize that MBR is gonna have a little bit of a different training curve because of the technologies, but we've seen it happen time and time again, that staff is gonna pick up with it nicely, we believe. And we've seen it, it's supported by what we've seen at other locations. And that's the end of my presentation. Oh, yes, I did want to bring you to schedule, where we are on the schedule.
Yeah.
Sorry. So preliminary design, as we said, we started around February. By July of next year, we'll be done. Detailed design, we're looking at somewhere around a 14-15 months period. For that, so we'll start that as soon as preliminary design is finished. That'll end around December of 2026. We need to do construction bidding and award. We've allowed about 4 months for that. And then we see this project as essentially a 3-year project to not only do construction, but then to commission, do startup, training and commissioning, so that Dylan and his team are fully functional. So that's a 3-year process. So we're looking at essentially an out year of May of 2030 to finish everything. I think I'm done now, right? Yeah, thanks.
So we'll have to request an extension from
Probably,
EPA?
yes. Yeah, we will have to work with the town, and I guess town council to appropriately communicate that there's gonna need to be extension to comply with
With the current
everything.
permit?
Yeah,
But to that point, they may not be in need for an extension either. There may be things that we can do in the meantime that allow us to limp by and meet
The permit,
standards in the short term, but not. in
With
the
our
long term.
current
Yeah,
plan.
with
there
that
may be
current
things
plan,
that
right?
allow us, because again, this is just knowing what we know about EPA or any regulatory agencies for that matter. They're not so inclined to grant long extensions. Short term, it's painful, but not as bad. Long term, that's a different story. I'm not saying that they won't, but just knowing what we do know with our recent history anyway, with
Yeah.
regulatory.
It'd be what, a 2.5 year extension,
Longer.
No,
longer?
4 years.
4
Yeah,
years.
Which I think is probably
October
unlikely.
of 26 is our.
Okay, I
current-
thought it was October 27, so
3.5 roughly.
3.5 years, okay.
But
and of course, we can
Mhm.
never speak for EPA or DES, but when they see progress, you can't, when that counts for a lot. So the commitment of the town is very important. Thank you for
Mhm.
your attention.
Another question I have, is this particular alternative, is this the alternative, the plant they operate in Epping?
Yes,
Right, and of course, there have been issues, questions about Epping, I mean,
yes.
I think we've heard in the past,
Yes.
that they were substantial, and that's one of the reasons why we ought not go down that route. Maybe you could speak to that a little bit?
Yeah, Epping, I don't know the history, but I learned a lot. But I don't know, I still, learning a lot and history is two different things. They really went from bad to worse. They started off, with, and we got this firsthand from the manager there. They started off with the technology when MBR was real new. I mean, we hear about the problems now. Their first facility went in around 2000.
Mhm.
There's been tremendous modifications, advancements with the technology since that time. And then somewhere in that period, they made a decision. And again, a lot of this is what I picked up firsthand. It's not something that's documented, but we also talked to the state, who was also part of that, and and they know what we're doing here. They've learned a lot too in all of this. And so when we spoke with them, with the community representatives, they decided to go, they had a membrane plant, and they said, guess what? This is not working. We're gonna take all these membranes out and we're gonna bring in new membranes. This membrane that they brought in was from an outfit in Germany. And they had received word that that the membranes were working well there. So hey, guess what? We're gonna bring them here. Well, they were working, and I don't have the history, but I have no reason to doubt that they weren't working well. They were not working in a municipal wastewater environment. And so that makes, that's very important, because you can be trying to strain out solids in two different liquids, one of them being, let's say, a brewery waste or whatever, and one being a municipal wastewater effluent and influent, and you're gonna have different characteristics. Remember what I said about screening and screening again. So those membranes did not like what was coming at them, and they weren't operating, and they weren't treating the way they should be treating and operating. And so that's when I say it went from bad to worst. There's a lot of other things that they did there. They decided to install membranes literally in the open. without a building
No
enclosure.
cover.
Yeah, and so they did not, you know, it's a cold climate. You might be able to do that in Southern California. Can't do it up here. You know, and so you ran into the weather problems as well. They didn't screen well, they went to a different technology. And when usually what happens when things go bad, people either man up or they run for cover. And I have a feeling that's kind of my own personal, I started adding my own knowledge base there, and I'm not sure that they might have done all the right things. You know, but they are doing a lot, very good things now.
Yeah, they built
yeah,
a
they are-
building last year.
Yeah.
They, you know, they've got it under a lot
Yeah.
better
Oh,
control,
And if I
right?
could just speak a little bit to what Mario just
Yeah.
said, so one of the main things that's important to remember in all of this is that when this facility in Epping was built, it was the infancy of this technology. There was really not a full understanding, especially with the engineering firm that built it, of the extent that it should have had to incorporate this into the climate that it's in. Okay, so why that's important is they were unaware of all of the technical issues that they were gonna run into by either selecting the piece of equipment that they did. What made matters worse, to Mario's point, the operators abandoned pieces of equipment. So why he talked about the screenings portion is they removed their fine screen out of operation because it was a maintenance nightmare. What that did was that made their membranes fail essentially, which is what led to, so there's, you know, it all makes, when you lay it out, it all makes sense why things compounded and got worse and worse. They didn't have the understanding that they should have to operate the facility. It was never designed properly. And with our meeting with DES, they are, I don't want to say they were gun shy, especially with Black and Beach, because that's the difference is we're not dealing with an engineering firm that has never dealt with an MBR, doesn't know the ins and outs. We have MBR experts that are incorporated with Black and Beach. They were entirely comfortable, especially in this application with our permit restrictions or requirements to go down this avenue.
There are no other MBR plants
Not
in New Hampshire?
Well, but to that point, over the last 3 or 4 months, we have looked at other plants in mountainous terrain, cold weather, up in Canada. We have talked to several other plants through Black and Beach that are similar to our setup, a ski resort type of application and those things. And we asked point blank to the state staff, are you okay with us going to the board with this recommendation? And they said, probably 2 years ago, if you had asked us that question, it would have been no. But now with the way Epping is running properly and with the work that Black and Beach has done to show other applications that are similar to ours, they're comfortable and they're okay moving forward with further design.
Yes.
One of the facilities in Canada that I think is, I think the three of you know, my hesitancy as well, even for surrounding this technology from what we had known before Black and Beach is one of the summits. There was a facility up in Calgary, I believe, or right outside of Calgary. So quite a bit colder than us in the wintertime as well. But what was staggering to me about that facility was it's actually it's a potable reuse facility. So they're taking their treated wastewater and that's being utilized in a potable.
Yeah.
I don't know if it's direct potable reuse or indirect, but they're utilizing it for that purpose. So again, just to show the level of treatment that it's receiving in temperatures that are colder than us. And I believe that was in a ski.
It was in a definitely in a mountainous
area. Yeah, I think it was right outside of Banff.
Very in tourism.
Yeah, I think it was Banff.
Yeah, right outside of Banff. So anyhow, it kind of checked all three boxes. There was some other ones that had relatively similar situations as us, but that one really, at least in my opinion, hit the nail on the head for a comparison to what we're looking at. So.
Thank you. Wendy, Bob, you have any?
No?
Margaret has a question.
Any questions? Yes, please.
Once upon a time, in a land far away, we did not have to have somebody on site at the wastewater treatment plant 24/7. Is that ever coming back, or that's never gonna happen again?
Well, obviously, the facility would be designed so it doesn't need to be manned all the time. However, I think working with the town, we recognize that eventuality may occur, so I'm sure that we'll be working with Mark and Dylan to set aside in case an overnight stay is needed, that staff has the accommodations to for that purpose.
This plant will, I think we've said it several times, regardless of the tertiary, secondary and tertiary treatment that we do, we're losing the lagoons in all of these options.
Which is a luxury.
So that's a luxury, and it has afforded us the opportunity basically to shut down the plant, especially over the weekends, right? So this plant will run 24/7. Now, whether there needs to be an operator actually sitting in there, we haven't worked, that's gonna be a question for DES and for our staff comfort that we can monitor it remotely and react if there's a problem. And that goes to the GAC because that does that granular activated carbon. That gives us another treatment process that helps protect us. And we'll build tanks into the plant and things like that to give us a little bit of flexibility. But those are things we're looking at right now.
And at a minimum, it's gonna be, no matter what we build, it
Right.
will be a 7-day operation. There will have to be
Right.
somebody here at some point, 7 days a week, but not necessarily for an entire
24 hours a day, yeah.
Can I go back to the cost summary?
Yeah.
So this is gonna take until 2030 to finish. Does the $19.8 million reflect the time change?
I can say right now that it probably doesn't. However, what you want to recognize, what you want to concentrate on, Bob, which is what we did, is we concentrated on the differential between these two.
Two systems.
So we treated the two of them the same.
Okay,
We treated the two of them the same. We were more interested in what is the budget cost for this facility at this time. We recognize that there's gonna have to be escalation for the midpoint of construction. We haven't done that. When we get to preliminary design, at the end of our preliminary design, you will have in your possession preliminary design drawings, a BODR, an opinion of cost at the 30%, where we're gonna basically base that on the drawings and also a revised schedule, implementation schedule. So that one then you're gonna see, okay, so
Okay.
what is the cost target for this plant? That one will have all those things, including contingency.
okay. Following up on that,
Yep.
so what isn't in this 19.8? It's the ski area line or septic.
Yeah, skier.
That's not in
lines.
there.
Yeah.
Decommissioning of the existing
Decommissioning
facilities.
plant, no.
Anything else that's major?
Administrative and operation type facilities, just
pipe.
the costs associated with the site. When we talk about, do we have rock here? What's the geotechnical conditions? Because that's gonna impact the cost. Some of these facilities are gonna be below grade, foundation requirements are gonna be impacted. It won't have the line works, the conduits. And it won't really have, we're gonna have to have, I think we've apportioned kind of a percentage for electricity. We're gonna probably need an electrical facility, a new switchgear set of switchgear, probably doesn't have emergency generation.
Mhm.
Doesn't have
The
that.
generator.
So those are some of the things that it doesn't
Okay.
have.
And
Those
it
are the
also
major
doesn't
things that I
have
can
the
think of.
credits that we would get from government agencies.
Correct.
So
So
I'm just trying to, in
Yeah,
my
well,
head, try to get to,
over and over, and Mario's getting sick of hearing it, but I keep pointing to what has been authorized
Right.
to date. and we can't answer that question fully right now. We're gonna, by July of next year,
Even
that's
before.
when we're gonna
30%.
know for sure, when we have that 30% final
Mhm.
design. That's when we're gonna be able to look at that 42 million, what we've spent to date,
Mhm.
and whether or not
Yeah.
we're gonna need more.
Engineering is. that in
Engineering
addition
is
to-
not in,
Yeah,
yeah,
engineering is not included for
absolutely.
there either.
Yeah, this concentrated, those two numbers were just for that liquid treatment
Okay,
portion of it.
I'm just trying to get my head around it a little bit.
Yeah, and I think
We know that that's an important question,
the,
Bob.
yeah, and
Sludge removal.
s-
That old
this,
sludge
that's the
thing.
decommissioning, yeah, yeah. So what I've concentrated on finally, Mario's beat me until I did, was that $6.4 million
Differential.
differential.
Mhm.
That's basically the basis of the recommendation. Both of them meet permit, both of them can be shoehorned into the site. But so now we've gone to the cost comparison and including operating costs for 20 years. Looks like the MBR will cost us somewhere around 6 million less to
Yeah.
operate, build and operate for
So
20
all those
years.
additional costs that aren't included in the number,
They're,
they're
they're,
gonna
they're
roughly be
equal.
equal.
That's
Yeah,
right.
As far as
And
you can see at this
With-
point.
they're
with
within
alternatives.
small percentages,
Yeah.
the way we're looking at it right now.
And we think that that differential between those two alternatives is significant enough to not be just an opinion. Because anytime we look at like maybe up to 10%, maybe up to 8%, if it's up to 8% between alternatives, you almost can start calling them equal, but this is like three
Three
times that.
times that.
Or, and so it, to us, MBR is a clear winner from an overall net present value perspective.
Hmm.
And both lagoons will stay operational to the end?
Yeah.
Or is there a possibility to eliminate one lagoon in the process?
We may be looking at that, although we want Dylan to feel
Mhm.
comfortable with
Cause
that.
that would give more room, that would
Yeah, yeah,
potentially.
yeah, because,
We-
We don't want to make a change though that
Right,
takes more.
I understand it's
also
still,
Creates
But it's a
issue with our-
possibility.
yeah,
We'll look at
Yeah,
it,
yeah.
and I think the biggest thing to that, Bob, is that we're gonna try to meet permit with the current plant
Right.
so that we don't have to request that extension. And I think the answer to your question is gonna be when we find out how we're gonna do that, whether or not we can take a lagoon out of the process.
Yeah, the bottom line is that we can somewhat model, if we can reconfigure one of the lagoons, take out sludge
Mhm.
out of one of them, we can start to almost convince ourselves as wastewater modelers that, hey, one lagoon partitioned the way we're thinking, we haven't done it, but partitioning would be the way we would approach it, seems to give us the same effluent out. We also know that Dylan's really running on the ragged edge right now with the age of that facility and that permit that he's got to meet, including removing ammonia, which is not.
Plus he's having a baby.
Not me.
But, so we.
And ammonia is an issue for us in
Yeah,
the summer.
absolutely,
Right.
and so if we can't. That. No matter what we think we can do, we're definitely gonna, this part of it is getting too close to home, we're not gonna just interfere with that. We think we're kind of bullish that it can work, but I don't wanna be, I'm not as sure about that we can run with.
To monkey with the- The event.
Because of the condition of the existing plant.
Right.
Already.
So how sure are you that you can get the existing plant to meet the EPA requirements? I mean,
If you want, I can help.
Go
you out
ahead,
on that.
absolutely. You've been thinking about it more than I
Yeah.
have.
I would say we're quite confident that we
Okay.
can, but again, keep in mind, this is a short-term thing.
Yes.
Not a long-term thing. part of the biggest issue with what we face with our ammonia concentrations in the lagoons is the sludge that's in them. So keep in mind, the sludge that's in those lagoons is from the last time it was removed was 1998.
Awesome.
So
Yeah.
we have a
16 years.
large quantity of sludge that's in there, and majority of that sludge is anaerobic or decomposing.
Sure.
So what happens is, and again, hopefully I don't sound like I'm beating a dead horse, but I've talked about this a little bit in the past. What happens is throughout the year, when the lagoons turn over, all of that ammonia, nitrogen, is just essentially being released off the
Yeah.
bottom of that pond when the water temps or the pond inverses essentially. So because of that, we could be chugging right along with our biological process, but as soon as that pond flips over, the ammonia concentrations go through the roof and the biology just can't nitrify.
Right.
Simply, they just stop working to their best or to the efficiency that they were working previously.
Right.
Anyhow, long story short, removing that sludge, making some modifications to the lagoons, and potentially even adding like an internal recycle, which would take a portion of the water from the back end of a lagoon, return it to the front end, just to make sure we're returning a lot of that biomass back into the process at the beginning phase.
Oh, that's interesting.
Yeah, it certainly, at least, and Mario and Will, please, we feel as if for the short term, we could certainly make it work. But this is all conceptual, obviously, right now.
Yeah, and anytime you're, at the end of the day, anytime you're making predictions on a biological system,
Well, sure.
it's what it is, and this is not a new biological system. We have, we're having to make estimates, and Dylan's gonna have to make estimates, so we'll work with them on that too.
Yeah, and remember, part of that total appropriation that town meetings approved to
Mhm.
date
Yeah.
was the maintenance of the
And
current
include,
plant.
right?
Yeah,
And now we've got another 4 years that we're tacking on to that.
Right.
Mhm.
So we gotta we're gonna have to analyze,
Yes.
because I think, what was it, 1.6 million out of the
Yeah.
total was for
Right,
maintenance of the current plant,
Right.
and if you gotta extend that time frame,
Yeah.
that could have a major impact.
Well, not only extend it, but
Right.
improve.
And then
the
make
operations.
improvements, right.
Yeah.
Well, just keep in mind though, that the sludge removal will be looked at as a decommissioning cost. So that would not necessarily be a operational or a maintenance cost.
Okay.
That would be a huge part of decommissioning.
And
Okay.
decommissioning is not part of what's been appropriated
right.
so far.
I thought it was. I thought we looked
I
at
think
that.
it is.
Oh, no, yes, the word, yes, decommissioning was
It is,
included in the
It
authorization.
was like 5 million.
Yes, we did include it,
Yeah.
sorry.
Same as
Yeah.
the line going up to the
Yeah.
resort.
It was the timeline that decommissioning is not part of the 2030
That's
timeline.
right.
Sorry,
Yeah. So I just wanted to make sure that I.
yep,
Let's do it.
okay.
Yeah.
Good, any other
What do you think, Chief?
comments, questions? I always appreciate going with what your hired professional recommends you to do. So, yes, I think MBR does seem to be the path to pursue to get to that 30% BOD in the summer. Next summer,
90% BOD, 30% fine.
30, sorry, right,
Yeah.
now I'm getting 30% final by what, July, August, I think you had in your
July.
your schedule, and then we'll get the more solid
Yeah.
numbers
You'll
and
see layouts.
and the
you'll see-
layouts.
You'll see a lot more.
right for an MBR.
Yeah, for
Plan.
the entire facility at that time.
Great.
All right,
Good, all right.
Thank you.
For
Thank
your
you.
time.
thank you, Mario, it was very
Thank you, Mario and Will. I'm
helpful.
gonna, you wanna do motion to adjourn, so I can stop.
Do I have a motion to adjourn our special select board meeting?
So moved.
A second,
Second.
all in favor?
Aye.
Dylan, what's the baby status?